So let's do a couple of problems. First one says 0.001 moles of NaOH is dissolved in 1.0 liters of water. We want to determine the OH minus concentration, the H plus concentration, the pH, and the pOH. So first thing you want to do is determine whether your acid or base is strong or weak. So NaOH is a strong base. So what that means is that it dissociates 100%. So if I have NaOH, it's going to go 100%, just one arrow, to Na plus and OH minus. So I have 0.001 moles per liter, so 0.001 molar basically, of NaOH. Since this is a 1:1:1 ratio, then that means that this is also 0.001 moles per liter. And again, only because it dissociates 100%. You wouldn't be able to do that with a weak acid or a weak base. And again, this would be 0.001 moles per liter as well. Now, the Na plus concentration doesn't really help us in anything, but the OH minus concentration helps us, because if we know the OH minus concentration, that solves part of the question here, and from that we can calculate all the other ones. So the OH minus concentration is equal to 0.001 moles per 1 liter, so it's 0.001 molar. From that, we can find the pOH. pOH is equal to negative log of the OH minus concentration. So it's equal to negative log of 0.001, which is equal to 3. Then we can find the pH from that. So pH plus pOH, we know for any solution, is equal to 14. So pH plus 3 is equal to 14, so pH is equal to 11. And then last thing is the H plus concentration. So to find the H plus concentration, you have different ways of doing it. You can either say, use this equation right here. So the H plus times the OH minus concentration is equal to 1.0 times 10 to the negative 14. And so we have the OH minus concentration, we have this number, so we can solve for the H plus concentration. Or the other way to do it is you can say pH is equal to negative log of the H plus concentration. And so the inverse of that would be that the H plus concentration is equal to 10 to the negative pH. And so it's 10 to the negative 11 basically, or 1.0 times 10 to the negative 11 molar. Let's look at the next problem. So we have gaseous HCl, so that's a strong acid, that means it dissociates 100%, is bubbled into 5.0 times 10 to the second milliliters of water. So basically 500 milliliters of water. We're told that 0.073 grams of the gas dissolves. We want to determine the H plus, the pH, the OH minus concentration, and the pOH. So first thing, we're going to convert our grams into moles of HCl. So we have 0.073 grams of HCl. 1 mole of HCl is 36.5 grams of HCl. And so that gives us 0.0040 molar. And we know that this is a strong acid, so HCl 100% dissociates into H plus and Cl minus. So we know that if we have 0.0040 molar, moles, not molar, I should say moles, of the HCl, then we have 0.0040 moles of the H plus and of the Cl minus, but what we care about is the H plus here. So then the H plus concentration would be equal to 0.0040 moles divided by, we're told that we have 500 milliliters, which is basically 0.5 liters. And so the H plus concentration is oh, I'm so sorry. The 0.0, I wasn't looking at my numbers here. The 0.073 grams divided by 36.5, that actually gives you 0.002 moles. So those are 2s, so this is 2 right here. And so that answer is 0.0040 molar. In my notes, I kind of did the 2 steps together. I apologize about that. So that's my answer for the H plus concentration here. All right, next I can find my pH. So my pH is equal to negative log of the H plus concentration. So that is equal to negative log of 0.0040. And so that is equal to 2.40. Just a quick note about sig figs. Because the pH is a base 10, with sig figs, if your concentration is 2 sig figs, the pH would be 3 sig figs. Those are the correct sig figs. But remember, on the AB exam, and on my test as well, I'm going to go with plus or minus 1 sig fig. All right, next let's find the pOH. We know that pH plus pOH is equal to 14. So that means that pOH would be equal to 14 minus 2.40, which is equal to 11.6. Another note about sig figs, this 14 is actually 14.00, so don't worry about the sig figs with that. All right, last bit here is, let's see, the OH minus concentration. So the OH minus concentration, you can do it in 2 ways. You can say the H plus times the OH minus concentrations are equal to 1.0 times 10 to the negative 14. Solve it that way. Or you can say that pOH is equal to negative log of the OH minus concentration. So the inverse of that would be that the OH minus concentration is equal to 10 to the negative of pOH. So that is equal to 10 to the negative 11.6. And so when you punch that into your calculator, you get 2.5 times 10 to the negative 12 molar. Next problem, we have 0.001 molar of barium hydroxide. We want to determine the pH and the pOH. So again, barium hydroxide is a strong base. So we know that BaOH2 is going to 100% dissociate into Ba2 plus and 2OH minus. Now, it is important to write your dissociation equation because if you didn't, you might make a little mistake with things that are not all 1-to-1-to-1 ratio. For example, in this one, for every barium hydroxide, you have 2 OH minuses. So that means that if you have 0.001 1 molar of the barium hydroxide, you'd actually get 0.002 molar hydroxide ion. So let's show the work for that. I would not expect you on the test to show me the work for that. You can just, write that this is 0.002 molar here. But the more work you show me, the better, though. So let's show that. So we have 0.001 molar. That means 0.00 moles of barium hydroxide for every 1 liter. And so to find the hydroxide ion concentration, you'd say for every 1 mole of barium hydroxide, you have 2 moles OH minus. So then these cancel. You end up with 0.002 moles per liter of the OH minus concentration. Okay. Now, the reason why we find the OH minus concentration is so we can find the pH and the POH. And so it would be easier to find the POH first since this is the OH minus concentration. So you can say that POH is equal to negative log of the OH minus concentration. So it is equal to negative log of 0.002. And so that is equal to 2.70. Actually, just 2.7 if you wanted correct sig figs. And then to find the pH, you can say pH plus POH is equal to 14. So pH is equal to 14 minus 2.7. So that gives you 11.3.